So we're going to try all this over again, but this time we're going to look for answers in exact form. That is code word for no calculator, and you're going to use your special triangles. So let's remind ourselves what the special triangles look like. It's the 1, 1, root 2 triangle, where this is 45 degrees. And then the other one is the 1, 2, root 3 triangle, where this is 60 degrees and this one is 30 degrees. So hopefully you've used those enough now that you can quickly sketch those out before you do an assignment or take a test. So now let's answer, you do the same principles, you follow the same principles as we did with the last one, the last lesson, or last skill I should say. We're going to first establish where the cosine is negative. And there are two places where it's negative. One is in quadrant 2 and the other one is in quadrant 3. The next step is we are given a ratio of 1/2, and that should trigger the fact that it's a special triangle in addition to this exact word. So remember, the cosine of theta is equal to -1/2, which is x over r. And that allows us to establish that the radius is 2, and the x value, that means the x value needs to be -1. So if I make my triangle with the x-axis, remember we're always using the reference angle as part of that triangle. This side is -1, this side is 2, which means by this triangle here, this distance has got to be root 3. And because we know that right across from the root 3, we have a 60-degree angle, we've just established the reference angle. So the reference angle is 60 degrees. That allows us to calculate the first angle in standard position, which is 180 degrees minus the 60 degrees, which is 120 degrees. If we go for the green angle now, we also know this is 60 degrees because it's, by definition, they're all going to have the same reference angle. And if we measure from here, going counterclockwise all the way past 180 to here, the second angle is 180 degrees plus 60 degrees, which is 240 degrees. So there are our two answers, and I did not pick up a calculator. So let's try that one again, this time with a tan function. So where is the tan negative? It's negative in quadrant 2 and in quadrant 4. And we are going to say, we're told that it's exact form, which means that we're hoping to use our special triangles. And the tan of theta equals -1. I'm going to write that as a ratio, which is -1 over 1. And we know that the definition is y over x. So that helps us figure out that the x value is 1 and the y value is -1. So if the x value is 1, that's one direction, and the y value is -1, that's the 1, 1, root 2 triangle. We know the blue angle is going to be the same size, where this is 1, 1, root 2. But don't be too quick. Make sure you put your signs in here. That one is a -1 in this case. The reference angle for that special triangle is 45 degrees. So both of them are going to have a reference angle of 45 degrees. So measuring the blue angle counterclockwise to the terminal arm, we have 180 degrees minus 45 degrees, which is 135 degrees. And the green one, we go nearly all the way around. We're going to go 360 degrees minus the reference angle, which is 315 degrees. So there are our two answers. Notice it's much faster to solve using special triangles than it is using a calculator. And let's do this one more time, final time here. The sine ratio, where is it negative? It's negative in this quadrant right here and in this quadrant right here. And the sign ratio, negative root 3 over 2, which is the y value over the r value. So we know the r value is 2. The r value is 2, and the y value will be negative root 3. And that's the special triangle, the 1, 2, root 3 triangle, so that's got to be negative 1. And for the green one, it's the same sized triangle. So I put my values in. I know opposite the root 3, we've got a 60 degrees. So the reference angle, I'll put that in red because I've been doing that all along, is 60 degrees. And the last step is I measure it going counterclockwise from the x-axis. So the first answer is 180 degrees plus 60 degrees, which is 240 degrees. And the green angle is 360 minus 60 degrees, which is 300 degrees. So there are two answers to this question. So this one is sometimes throws students for a loop because it's asking for the exact value when the tan is undefined. So let's try and figure out what that would mean, because the tan ratio is y over x. And so to get an undefined value, it means that we are trying to divide by 0. So undefined means that x must be 0. So if we take a look at the quadrant, where is the x value going to be 0? So if we go counterclockwise all the way to here and end right here, this point is going to have an x value of 0. So one answer is 90 degrees. The other place that the tan ratio is going to be undefined is if it goes all the way around here to here, because also on this point too, it's going to be the x value is 0. So the second answer is 270 degrees.